Hello all, welcome to my YouTube channel. In the last video we have discussed how to create the bar chart with respect to the ordinal data, and then we use a hue property and we visualize how much people's who's give the rating of the good bad are satisfied or dissatisfied. This is what we did in our last video. Now today video is based on the some other features in the data set. If you see, these are the features which have the numerical value, and in this mostly we visualize in the last video. So say the in-flight Wi-Fi service already we visualize, so let's cut it from there. Then ease of online booking to the cleanness, everything we visualize. So now we have mostly the 3 columns left which we are going to analyze in that. These are the numerical columns and we will see one by one, and if and we try to find how to detect the outlier if and how to remove the outlier. So what are the outlier detection techniques we are going to discuss in this video. So let's take one by one. I'm going to take the first as a flight distance. So basically if we talk about the outlier detection techniques, the first technique come in my mind, that is the interquartile range. So how to calculate the interquartile range, first I will show you in a few lines of the code. Then we will be move our analysis to the box plot, to the percentile, how we will decide it will be the outlier, and how we're going to remove the outlier, and how much the outlier should be removed. So our data should not the data should not face the data leakage problem. That's all we keep in the mind, and let's start today's video by writing the code for calculating the interquartile range. So before calculating the interquartile range, we should see how to calculate the percentage. So for this we are going to use the numpy. So np.percentile, we are going to give over the columns here. So let it be the flight distance. Now which percentile you are calculating? 25. So let's see how much it is. It is the 414. And similarly, if you calculate for the 75 percentile, you have to be changed here. In place of 75, it should be the 25 percentile. But how will we calculate the lower bound? So let me denote it with the lower bound, and lower bound is the NP percentile of 25% minus 1.5 multiply with IQR. So we have to be calculate first the IQR. So what is my IQR? IQR is what? NP dot percentile of 75% minus, it should be the 25%. And what is my upper bound? My upper bound is the same NP dot percentile flight distance of, in place of 25 here should come 75, and here in place of minus it should come plus, and same like that. So I can print here what is my lower bound and the upper bound. So my lower bound is minus 1579.5 and my upper bound is 3736, but mostly it is the flight distance, so it is starting from the 0, so we don't need to be bother about the lower bound, but we should be bother about the what is my upper bound. So calculating the percentile and getting the value is not make that much sense compared to the plot. So now this is the time to plot the box plot as well as the KD plot, that is a density plot, and there we visualize and see these two things how it makes the sense. So first let me plot the box, and as well as with respect to the second axis I will plot the this one KD plot. So for this almost we have all the code, all the analysis in the above charts. We already did a lot of charts in this project. So let's take the background from the above charts and do quickly. So if you are watching my video continuously, you are now familiar with this. The figure and two axes are defining. I'm defining the subplot of the one row and two column. I'm giving the fig size here. Now this is the subtitle is coming, that is the flight distance analysis, font size and the weight you know very well. And the first axis I'm going to draw the box plot. So this is the set the title of the box plot. I'm going to use the SNS dot box plot. So y is my flight distance, data is coming from the DF and it should plot on the axis 1. Now it's time to plot the KD plot. So what I'm going to do, you have to be change here the title and the axis. Now the title is the KD plot. You can write here the KD plot, and similarly you can use the again SNS to draw the KD plot. So SNS dot KD plot, the flight distance is the column. Data is coming from the DF, and I'm going to draw the axis 2. What is the shade? I'm making the 2 to fill that density, and I'm defining one color as well as here. Now adjust this plot by giving some y-axis title, x-axis title, and then we draw the vertical line of the lower bound and the upper bound in the KD plot. To draw the vertical line, there is a function of AXV line. So axis 2 AXV line, lower bound already we defined above. We'll put the line straight, color and label. It's pretty simple. Legend is that to show what is the label in your plot, and we are setting the x label as the flight distance. But it's not enough only to draw the vertical line. We should see what is the value as well. So here I'm going to use the function of the annotation to write on the lower bound and the upper bound what is the value of the lower bound and the upper bound, because it is easy now. If the flight distance is greater than 3736, we can treat it as an outlier. So it's pretty simple. We use the annotation function. We have an upper bound where it should plot on the upper bound in this, and this is the some style design. I'm not using the annotation of the lower bound as well here, because it's pretty simple, because lower boundaries will not make sense of this value as the flight distance, as distance start from the 0. Let's see how is our plotted. So this is the box plot, and we can see our the KD plot. So if you see the distance is near about I can say it is near about the 3850. I can consider more than this the distance. It's showing the outlier. Same in the box plot, if you can see here, the outliers will start from here, and it will be telling these points are the outliers. So there is some distance which we can't visualize in the KD plot, but we can see in the box plot some value at the 5000 is extremely outlier, which can affect our the model. So these points we should be removed, and let's we will see how we will be removing these points. But before finishing the conclusion about the flight distance, I will show you how we can see this help of the percentile value as well. So for this we should write one function which calculate the percentile. So I'm writing the function define percentile. At first view, I'm going the start point, and I'm going to give the end point, as well as I'm going to give how much jump it should take, and mostly it start from which data and which column I'm going to visualize. Okay, so for I in range of start and jump, first it will take the data column values, and it will be sorting the values. Now once I sort the value, I can calculate the simply what is the percentile. So I can print here the percentile value is the my format, the at the 0, for at the 0 what the percentile value. So it is nothing, it is just I'm dividing with the 100 the values, and for the getting the 100 percentile, what I can do, print and the format of the 100 percentile. Okay, we can test this function by running it one time, and we can see data is my DF, column is my flight distance. I am starting from the 0, I am end at the 100, and should take the jump of 10. So 0 percentile 31, 10 percentile is that. But if you see, this 0 to 90 percentile is making sense, but what is not making sense, the value from the 90 percentile to 100 percentile. At the 90 percentile the values are 2750, whereas in the 100 percentile the value is the 4983. So how it within the 10 percentile it is jumping from the actually the double volume, it is jumping from 2750 to the 4983, near about the 5000. Not the double, but it will mostly approximately double it is the jumping. So from here seeing the percentile, I can't take the conclusion what is happening between the 90 to the 100 percentile. So for this I'm going to run this function again. So let's see what is happening between the 90 to the 100 percentile. So the percentile at the first view, I'm just changing the starting value, that is the 90, and I'm changing 100 will be the end, and it should take the jump of 1 now. So if we will see, so if we see the 90 percentile is 2750, again 91 up to the 99, again it will make sense. Then again there is a near about the 11,000 jump from 99 percentile to the 100 percentile. So if you want to go further more analysis, we can modify this percentile function to one step ahead, and we can now visualize from 99 to 99.1 to 100.0 for how much the percentile is changing. So what I'm going to do, I'm going to write here the percentile at the second view. Percentile at the second, sorry, it should be the third view here, because already we see from 91 to 100. So percentile at the third view, I need to change this format little bit. Here it will be start from the 99 plus I, and it should be the 99 plus, and here I can give it is 0.0, and it should be the 1.0, and it should take the jump of 0.1, and I now need to define this start and jump here. Okay, I need to define this one. I need to, okay, here should be the, well, I come due to the, I have to be use here the arrange. Okay, so let me see, 99.0 percentile is giving the 382. Again, it will make sense. Only the point is after something will happening, that is the 99.9 percentile. After this only something is happening. So if I want to remove the outlier, I can remove the flight distance which is greater than the 3995. So let me see how many rows will come once we remove the outlier after this 3995 distance. So this is the flight distance. Now flight distance is greater than 3995. I'm treating as an outlier. So let's see how many rows. There are the 99 rows. So these flight distance which is greater than this, I'm treating as the, so I'm trying to remove here the 99 rows based on the flight distance. So we can write the comment as well here. So to remove the outlier from this column, we can select the flight distance which are less than 3995. Okay, so this is what we did for the flight distance. Now this is the time to do for the departure time and the departure delay. Same things we will be do for both of the columns. So now I hope you understand this one, and if you have any doubt you can ask, and this should be the clear. So to detect the outlier, we discuss the three techniques here: the interquartile range, the box plot, the KD plot, and the how the percentile is helping us to see how many outliers in our the data set. So let me replicate the same exercise for both of the columns. So to replicate the same exercise for both of the columns, I write the one generalized function. Let me paste it here. So this is the outlier detection technique. It is considering the what is your data and what is your k column. It calculating the interquartile range, what is the IQR, to calculate the lower and the upper bound. Then we are defining here the figure. We are going to analyze with the help of the box plot and the KD plot. So box plot and the KD plot we are visualize in this part. So same exercise how much I did in the previous, the same things I replicated here. If you understand the above exercise, there is no problem to understand this one. So let me call this function outlier detection, and outlier detection I have to pass my data def, and let's pass my the column. So what is my column name? The column is the departure arrival time convenient. So once I run this function, I see here, no, okay, not this column should be, no, we did one mistake here. It is actually the ordinal data. We don't need to be visualize here. We have to be give the different column, that is a departure delay in minutes. Sorry for this one. I just use the different, so that kind of a curve come previously. Now we are using the departure delay in the minute, that will purely numerical data. 30 is the upper bound, and again the lower bound we don't need to worry about it. So additionally I add the mean and the median line in this. So if you see the very simple, what is the mean, you have to be right here. This is the mean and median code. That is the additional things we did in this exercise. Now if you see, the outliers are starting very early, so we can't believe in this box plot and the KD plot. So I have to be go for the percentile. So let me call my function again the percentile at the first view. and let's see how it is varying from the percentile. So in the place of the flight distance, I am passing the column name as the departure delay, and it is start from the, I think, 0 is, and it should take the jump of 10. So it perfectly makes sense. There is nothing to be worry because again the jump is from the 90 percentile to the 100 percentile. So I again will run this one as well, and it will be now come from the 90 to 100, 90 to 100, and it is a jump of 1. So 99 percentile is pretty clear of 182, and 100 percentile is value 1592. Again something is happening between the 99 to the 100 percentile. So let me now call my function percentile at the third view. So in place of the first, I am going to use the third, and I no need to give the start end because already I fix it. Okay, so 99.9 percentile is telling about the 376, but still 99.9 to 100.0, there is something is happening. Now how to visualize it? Because here my box plot is failed, my KD plot is failed, now my percentile view is also failed. So now pictures come here, we need again to believe on our the graphs. So I'm going to plot what is happening at the 99.9 percentile. I'm just simply plotting what is happening at the end. I'm calculating here this departure delay in the minute. I'm sorting this value and I'm plotting what is happening between the last 20 values, and I'm leaving the last 5 values. I'm going to analyze what is happened between the last 20 values. So let's see it here. Then we can see there is a sharp jump at 750. Now the things is going worst from the 750 minutes from that, because it's a departure delay. Now this is the smooth line I'm getting up to the here 725. Okay, this also I can consider not this much high jump here, but if you see from the near about the 750, it is a slightly jump of the 100 minutes. So this is very strange. Similarly, you can visualize it from the another value as well. So last 40 values, what is happening? Okay, so last 40 values I see there is nothing change, only I can see the change is this one. So what I'm going to do when my everything is failed, I'm going to be conclude based on this. Okay, the departure delay which is greater than 750 is an outlier for me for the column of the departure delay in the minute. To remove the outlier from the departure delay time, we are considering the flight which I have delay less than 75 minutes. So which are greater than 75 minutes are the only the 9 rows. So these 9 rows I'm going to be removed from my data frame. Similar analysis you can do now fastly for, so let me correct it as well as here also. And this is the arrival delay in minutes. So what I'm going to do, I'm going to be right here arrival. Similarly, like in the departure delay it fail, like similarly it is a fail in the arrival delay also. Box plot and KD plot is not make sense. So what I'm going to do, you have to be see the percentile at the first view and at the third view as well as in the second view as well. So here I just change my column name. So arrival delay in minutes is changed here, and it start from my 0 to 100 and should take the jump of 10. Okay, so 100 percentile value is NaN. It is interesting why the 100 percentile value is NaN. So something is missing here. What is we are missing? We in our analysis we forgot to check is any column is containing the NaN value. So if NaN values, that means the last value is NaN. So 100 percentile is we are getting is a NaN. So first, before going to the outlier detection, we have to be do one thing. We have to be check is this column containing the NaN values or not. So it is easy method to check is NaN.sum. So okay, so 310 values are the NaN values. So I need to fill this 310 value. In place of the mean, I am so I want to fill this 3110 values. So I choose to fill with the help of the median. So now let's see if any column of this data frame containing the NaN values or not. So now everything is pretty clear, nothing is containing. So let's run it again. So now you see 90 percentile 100 percentile there is a 1584. This is the huge jump which I can't believe here. So let's go back again and now do this one. See from the 90 to 100 with the jump of 1. So again 99 percentile. So what I'm going to do, I'm calling the last function, that is the percentile at the third view, because second view also doesn't make sense. 99 percentile have and 100 percentile have the huge gap. So I'm just have to be change the column. Okay, so 99.9 percentile, again 100 percentile, there is a huge gap. So again I can't believe this percentile method, this method is also fail here. So again I need to, what I need to do, I'm going to plot my values. So it is and let's see of the last 40 values to 5 values. Okay, so again I can see here is a big jump. So let me goes to last 20 values. Okay, and now I can see this is a flat, and again there is a jump of 7. So if it is a greater than 700, also there is a jump is coming, that is starting from near about the 645. So based on this jump I can conclude how much outlier I need to be removed. So I am removing just for an example of the after the 1000, but this outlier techniques is work well if you have the domain knowledge. If somebody is working for you in the with the same domain, then you can be remove the outlier pretty clear compared to just guessing it. But if it is greater than 1000 minutes, I'm going to be remove, and I'm keeping the rest of the analysis in my data frame, which is greater than 1000 we are going to remove. So there is a 3 row, but if I leave last 5 value, and then if I see here the jump is coming near about the 750. So if I see here the 745, if I write here 740, then there is a 9 rows. So I can take the decision of the 745 also of this jump, and I can take the same decision at 645 else also, because there is a sharp jump as well as there. So near about the 15 rows. So I conclude here the 645 minutes, which is greater than, I'm going to be removed. So now up to this time what we did, we choose here which we are going to remove, but we didn't remove. So now we write the function to remove the outlier. So define remove outlier, and as pass as the data in this. So it can work for other function as well. So I'm going to be know what is my shape of the data, how many rows I have. Then I'm going to be considering the flight distance which is less than 3995. I am considering the departure delay which is less than 750, and I'm considering my this arrival time which is less than 645, which is the 645. And this is the new data frame which is the which is filtered with this much rows. And then what is the number of the outlier, that is a minus v, and how much percentage of data we remove, that one we will see once we run this function. So in place of the data we have to be pass only the df here. So number of outliers are the 120 outliers I'm removing, and there are the this much rows in our data frame. So near about the 0.1% only data I am removing. So we can proceed more, because this flight distance we are considering, we can remove more data. But this is an example, I show you how you can remove the outlier, what are the analysis you can perform. So let's keep this data in our data frame, and do our analysis based on this data frame. So let's call the new df here and store. So here then my data frame become the new df. So let's check what my new df dot have. So similarly, it's just remove the 0.1% of our data. We can't remove the 30%, but we can remove the 5% of our data. So if you want to remove more data here with help of the flight distance and the departure delay, you can do it. And let's see how much percentage you will remove and how much it affect to the model building. So this is what we have the outlier detection technique. I hope you understand this video and like this video. If you like this video, then please like, share and subscribe to my YouTube channel for the more videos. And we are mostly completing our the data analysis part, and in the next video we will discuss about the correlation analysis. Then we will move forward towards the our model building. So this is what in this video. I hope you like this video. So please take care, and meet you soon in the next video. Thanks, and bye bye.